Welcome to our project, the HDL testing platform. With this video we want to give you a short overview of our project, and now let's get to the technical stuff. With this project we wanted to implement an easy-to-use VHDL platform students at the Technical University Vienna can use. So we've implemented the project, and as you can see here we have an setup at the university with one server for compilation purposes and one FPGA to test on. And now to the server part.
At the server there runs a custom C program which takes all incoming files from a user and automatically synthesizes them, implements them in the partial reconfiguration parts, and generates bit streams which is sent to the FPGA. Additionally, JSON files are generated which tells the FPGA user informations. And now let's have a look into the Vivado project. Here you can see a short overview of the top file. It is just a connection between the block design, the P blocks, and the multiplexer. Now let us jump right into the project. You can see the three parts: the top file, which connects the block design and the MUX, and the top also implements 8 partial reconfigurations. These are used for the user files, and each user does fill one partial part. Let's take a look at the block design. It consists of 3 major parts. One part is the sync processing core, which is used for the controlling of all peripherals, and also it is used for testing via the GPIO blocks. Another part is the hardware ICAP. It is used for programming the partial blocks, and as you can see there are 8 GPIO blocks implemented. This means there's one GPIO block for each partial reconfiguration. Additionally, there is a clock manager which provides a specific clock to the partial reconfigurations. All the outputs of the block design are connected via the top VHDL file to the MUX, which is responsible for connecting the outputs of the partial reconfiguration to the hardware. This is a short overview of the Vivado design, and now to the design of my colleague, the ARM design.
So here you can see the final design. It's a webcam implementation on the website itself. We have different partial designs already prepared for you, so we can have a look on 2 different examples. Everything is stored in this test JSON file we're going to look at. The first one is test user 1 with the design and the P block, because as we have seen 8 different kind of P blocks, and for the MUX we already keep track on which peripheral the user should be capable of switching. So let's test the first user. The first user is allowed to use the first 3 pins, and the design is configured to toggle the RGB LED. As you can see, we are toggling the RGB LED with no problem, and to show that 2 different kind of people are also capable of working on the same FPGA board at the same time. Now we're going to switch to another user. The user sees welcome for the first time if the feedback is flashed, the bit file is flashed. Afterwards he always gets welcome back. As you can see, the user is capable of using pin 0 and pin 3 to toggle the different kind of LEDs on the bottom. Now I'm going to add a pin for the user to toggle as well, and after some reload, you can see the pin is going to show on the web page as well. So let's switch back to test user 1. And as you can see, it's also toggleable independently of the other one. Thanks for your attention.